Now the topic is class D commutation, right? So it is also called as see, we are having different commutation, different names for it. This is also known as voltage commutation, right? This is also called as voltage commutation, and it is also known as auxiliary commutation, auxiliary commutation, and it is also known as what, parallel capacitor commutation, right? So these are the different modes we are going to explain here, right? In this particular class D commutation, right? So see, I have not mentioned here, let me wait for a while. Yeah, so this is the basic diagram of class D commutation. We are having two thyristors, one is the main thyristor and TA is the auxiliary thyristor, and the diode, inductor and the capacitor we are having, and voltage supply at the beginning we have given. This is the load. So how this is going to be operated, right? And we need to go for taking some kind of assumptions, like in the case of previous commutation methods. We need to assume like a load current is constant and capacitor is initially charged by Vs, right? Yes. Now what is going to be happen? So initial conditions are both the SCRs are in off position. Now if you clearly consider this SCR is in reverse biased condition, thereby what is going to be happen, we cannot, I mean, the capacitor cannot discharge anything, right? So in order to make the capacitor to get discharged, right, we are going for the third one, right? This is the first one, right? This is the second one. So in this particular group, what is going to be happen? So TA is going to be kept on by giving some kind of gate signal. We are making the TA is to turn on. So the flow of current should be like as shown in the figure. This is the way how the flow of current is to flow, right? This is Vs. So the capacitor will charge due to the loop current which is flowing in this particular circuit. This is the loop current, right? So we are having the polarities of capacitor like this, right? We are having the polarities of capacitor like this, and we are having the polarities of capacitor, right? So what is the voltage across this capacitor right now? So this is the supply voltage, is the capacitor. The reason is what, it is going to be charging up to the supply voltage. So as soon as the capacitor is fully charged, what is going to be happen? T8 will get turns off. The reason is what, it is due to the fact that as the voltage across the capacitor increases, the current through the TA decrease. I mean, TA in the sense what, auxiliary resistor decreases, since capacitor C and TA forms a series circuit. That means entire voltage is going to be get by this particular capacitor. So there will be, the current in this particular auxiliary resistor will get decreases. So thereby it is going to be turned off. As it is going to be turned off, this is what the third one, right? This is the third one. As it is going to be turned off, the corresponding figure will be like shown in the figure. Understood over the corresponding figure. So now what is going to happen? Now we would like to turn on the T1, right? So what we are going to get, so there will be two loops of current. This is one loop 1 and this is what, the loop 2. And loop 1 used to flow through the IT, the same current, that is nothing but what, I0 current, and loop 2 current will discuss about what, discharging process. So what is going to be happen, loop 2 is just meant for discharging. So in loop 2, commutation current, that is capacitor, discharges through it flows, right? Commutation current flows. So in loop 2 the current is nothing but what, commutation current. That means what, from where the capacitor get discharging, right? So after the capacitor has completely discharged, what is going to be happen, its polarities, right, its polarity will be reversed, right? Its polarity will be reversed like as shown in the figure. This is what, fourth one. So I can consider here the polarities can be reversed like this, minus plus. Understood? So as the reverse discharge of the capacitor cannot be possible, the reason is what, it is we are having a blocking diode D. So in this mode, what is going to be happen, T1 is on and TA is off, right? And whatever the supply voltage we are having, whatever the voltage we are having in the previous case, that will be changed into negative Vs, right? Negative Vs, right? Now, so to turn off T1, now if we would like to turn off this particular T1, definitely to turn off T1, now what we have to go for, we need to turn on TA, right? TA should be turned on. So I just have turned on TA. See, the polarities are like in the previous case, that is what we are having, negative ES, right? Negative ES. Now the capacitor with polarities negative, this kind of polarities will appear across this particular T1, right? And hence it got reverse bias. See, we have been turned on this TA, that means it is short circuited. So whatever the voltage we are having this at this particular condition, it will be occurring across the reverse by the thyristor T1. So negative is connected to the anode here, so it will be what? Reverse bias. Negative is connected to the anode, so it will be what? Open circuit or reverse bias or open circuit. So it will be turned off. So the T1 has been turned off. Now what is now there is some kind of flow, right? There is some kind of flow of current. So the flow of current will be like as shown in the figure. Understood? Or and this current will flow until the capacitor voltage changes from negative Vs to positive Vs. Negative Vs to positive Vs. Negative Vs to positive Vs. So this is how the capacitors are going to be flowing, and as soon as the voltage polarities of the capacitor changes to plus minus plus to negative, so negative minus negative plus to negative, so what is going to be happen? This negative is appearing over this particular anode, so thereby it is going to be turned off. So initial condition will be existing like this. Again the mode will be repeating like this condition. Understood or what I am saying? So this is what. So if at all, if I want to draw the waveforms of this particular what I mean to say, commutation method, so how we are going to draw the waveforms, right? Yeah. So if I am going to draw this particular waveforms, right? So first I have given the triggering pulse to this thyristor 1. So in the thyristor 1, if you consider, when you are going to switch on the thyristor 1, definitely it is in off position. So what is the voltage across it? So the voltage across it will be 0. The voltage across it will be 0. Understood? Over now. So what is the current flowing in the particular condition? So it is a constant current it is flowing off. So I naught will be what? Constant like this. Understood? Over and moreover, so if you go through a particular condition here, what is IC? So IC is nothing but it is the discharging current what here is flowing off. So that what is going to be happen? It is nothing but it in the positive half cycle there will be the IC used to flow, but in the negative half cycle this reverse blocking diode will definitely block the current. So that is the only reason what is going to be happen. We are having IC current for some time. That means what? Nothing but the positive supply, positive cycle, and in the negative cycle it will block the current, that is what? 0. Understood? Or now what is the current passing through this IT1, right? T1. So the current is of two types. One, it is flowing like I naught, it is flowing through this particular load, that is nothing but I naught, and second is the loop to current. So that means that is due to this capacitor. So if I go through applying this kind of supply over here, signal and system concept, so IT1 will be like this. In the positive half cycle we are having like this, and load. See, in the negative half cycle we are having load current is constant and it is 0. So constant plus 0 will be what? Constant. This is condition. Understood? Or hope you have understood. And we are having load and plus this condition. So these two signal waveforms have been added like this. Understood? Or no? So what is the capacitor? Initially it is in higher position, that is positive Vs, right? So what is going to be happen? Again and again what is going to be happen? It tends towards what? Negative supply. It tends towards what? Negative supply, right? And stayed in negative. Understood? Or what I'm saying? Yes. Now what is going to be happen? Now I would like to switch on the thyristor TA. Right, when I am going to switch on the thyristor TA, what is going to be happen? So in order to make this TA on, it should be off, right? So negative Vs will appear across this T1 in order to get turned off. So that means what? There is some kind of negative voltage. So across the thyristor. So that means what? There is some kind of negative voltage across the thyristor at the beginning, and then it is going to be 0, and then we are having the Vs value as a constant. Understood? Or the same Vs is going to be applied. Understood? Or next, as the current as the thyristor T1 is in off position, so the current will be what? 0. The current will be what? 0. Understood? Or so the capacitor current is also 0. The reason the capacitor current is also 0. The reason is what? It is a reverse blocking condition. So there is nothing to be right conducting over here. So the capacitor current will become 0 at this particular position. That means what? The capacitor current will flow in negative fashion for some time, right? Flow in negative fashion for some time, and then it reaches 0 and staying at 0. Understood? Now, so I naught used to flow like this in the auxiliary thyristor also, since up to I mean, I naught used to flow in this particular fashion. Understood over. Later on, when TA is going to get off, so I naught is also going to be 0. The reason is what? At this particular position, after it charges, after the polarities are going to change from negative Vs to positive Vs across the capacitor. So definitely negative and this anode is going to be cancelled out here, so TE is going to be cancelled out. So finally what is going to happen, there is no means of getting any kind of capacitor current to get discharged like this process. Understood over. So that is the only reason capacitor current is also 0 here and I naught is also 0 here, right? So now, so as the modes passing over, so there is a change of voltage from negative Vs to positive Vs linearly and staying at Vs. Understood over. So this is all about the waveforms, I mean class D commutation, right? Thank you.